I'm very pleased to now turn things over to Norman Yan. Norman has previously worked with the Ontario government, York University, and today works with the Friends of Muskoka Watershed. Norman has devoted half a century to work to understanding human impacts on Ontario's lakes and how the damage can be fixed and its reoccurrence prevented. In 2014, Norman assumed chairmanship of the Friends of Muskoka Watershed, which is a not-for-profit corporation that fosters understanding, choices, actions for watershed management. Norman, I will turn things over to you now.
Thank you very much, and I'll share my screen. Hopefully that has worked.
We are seeing, oh, yep, perfect. Thank you.
Well, thank you everyone for joining us on this frigid morning. It was minus 28 in Bracebridge this morning. And I wish I had a fireplace that I could sit in front of, and you'll see why over the course of the talk. Let me start just by providing my own quick acknowledgements to the people that made this project possible. The Trillium Foundation for funding. Most importantly, over 1,000 volunteers who have hauled their ash to help make this project possible. And how we got 1,000 people so involved is something worth considering. Various academics, especially from Sean Watma's lab at Trent University, 3 wonderful sugar bush operators, Ken, Mark, and Wolf, the staff at Camp Big Canoe. So you'll see that we're working in these sugar bushes and at that camp, our own staff, our board, and especially Daniela and Georgian Bay Biosphere Reserve for the opportunity to speak to you. Let's start by talking about osteoporosis. We all have a sense for what that means, not a detailed medical understanding maybe, but we know calcium is important for our bones. It's also important for our muscles and nerves to work properly. And people that have osteoporosis, there's something gone wrong with either their calcium supply or their calcium metabolism. And it affects 1/3 of senior women in Canada and 1/5 of senior men. So there's probably someone on this call that might suffer from the symptoms of osteoporosis. Well, if we are 6% calcium by weight, so everyone on the call has 4 to 5 pounds of calcium in their body, it should be no surprise that calcium is important for all living things. So where does it come from? Well, it comes from the atmosphere. Rain and dust supply calcium. It also comes from underground, from the mineralization of rocks. And that's it. That's where we get our calcium. And then it's recycled in forests, but slowly moves downstream. And so we could ask the question, could our watersheds and the plants and animals they support, which also of course rely on calcium, suffer from a kind of ecological osteoporosis? And this would be the case if soil and water calcium levels fall below the levels that the biota needs. And we would expect that the animals and plants with the largest calcium needs would be the ones that suffer first. So what creatures might that be? Well, in the water, I think we'd all recognize that it's the crusty animals that might have the most need for calcium. So crayfish can be 30% calcium, snails 30% calcium, turtles with their wonderful rib cage that's turned into a shell have 2 to 3 times more calcium needs than we do. Fish can have either more or less requirement. Trout are only 2% calcium, but bass are 8% calcium. I spent much of my life working on the animal plankton that keep our legs clean, and they can have as much of a calcium requirement as us. They're like little tiny lobsters with shells. So there's lots of creatures out there that have a high calcium need in our lakes, and it turns out that calcium levels in our lakes have been falling rapidly and dramatically. We're fortunate in Muskoka to have the Dorset Environmental Science Center located over southwest of Algonquin Park. They have sampled 7 lakes every 2 weeks to a month for the last 40 years. And here's what's happened to the calcium levels in those 7 study lakes. They've fallen by 35 to 40% over the last 40 years. Now, the percent decline doesn't matter so much as the absolute level of calcium in the lakes and how low it might be. Here's a map of the watershed. Here's Georgian Bay over here, Algonquin Park over here. And the dots represent calcium levels in about 600 lakes that have been sampled in the watershed. Red dots have less than 1 or less than 2 milligrams per liter of calcium. And that is a level at which crayfish start to die, for example. And just scan the whole watershed and you'll see there are red dots, red symbols located across the watershed, including over here, close to Georgian Bay, and certainly near Algonquin Park. So half the lakes in the Muskoka watershed currently have calcium levels low enough that calcium-rich biota in lakes are at risk or already suffering. So we have an unacknowledged ecological osteoporosis problems in our lakes. Now, lakes get their calcium from the land, so might there be a problem with calcium levels on the land as well? Well, it turns out that trees, like biota in lakes, differ in their calcium requirements. So if you compare a maple and a birch and a conifer, here's the calcium levels in the wood of the maple, 3 times higher than in birch and 5 times higher than in spruce. Bark, 10 times higher. And even in the leaves where the calcium is not structural, but has more metabolic needs, there's a little more, twice as much calcium needed in the deciduous trees than in the conifer. So if there is an impact of falling calcium levels in the soil, we might first anticipate damage to hardwoods, especially sugar maple, that has the highest need among trees in our area. Well, it turns out there is a long-term decline in calcium levels in soils. Now, this is a modeled response. We haven't been sampling soils since 1850, but done in Sean Watma's lab at Trent University. And this is the what's called the base cation pool. Base cations are calcium, magnesium, potassium, and sodium. So you can see the dominant base cation was calcium in blue, and its levels have fallen, particularly from, say, 1920 to about 2000, by about half a ton, 500 kilograms per hectare. The model suggests that our soils didn't have much calcium to start with, and they've lost about 40% of it, about half a ton of calcium per hectare. Other base cations have fallen too, but the biggest dramatic change is in calcium. Well, what might that mean? So the Ministry of the Environment's Old Air Resources branch sampled 35 sugar bushes across central and southern Ontario, starting in the early 80s. And here's just some data that were shared by the Air Resources branch, again with Sean Watma's lab. And you'll see quickly why I'm working with Sean Watma here. So between 1985 and 2005, there was a 60% decline in calcium levels in the surface soils. And that was associated with about a 20% decline in calcium levels in leaves of sugar maple. And that's an average. The sugar bushes up in Haliburton, Muskoka, Nipissing, Parry Sound suffered the biggest decline. And that had impacts on the health of the trees. In every one of these sugar bushes, a number of metrics were used to assess tree health, like canopy openness, tip dieback, annual accumulation rates of wood. Those were all scaled and compared and used to ask if the forests were healthy or unhealthy. And about half of the sugar bushes were considered healthy, 18, and the other half were considered unhealthy, a nice statistical split. And the biggest difference between them was that the unhealthy sugar bushes had lower levels of calcium in the soil and lower levels of calcium in the leaves. So this long-term decline in calcium in the soil has impacted the health of forests in Haliburton, Muskoka, Nipissing, and Parry Sound. So why are the calcium levels shrinking? We can kind of use a automatic banking machine analogy here. The amount of calcium in the soil bank is a function of deposits of calcium, how much calcium was added, and the rate at which that calcium is removed from the soil. So the glacial history provided the initial bank. You can think of how much money your grandparents put in your initial bank account when you were a child. Much in Haliburton, Muskoka, Nipissing, Parry Sound, a lot of the glaciers removed a lot of the soil, dropped it further south. And then the rock that's exposed when the glacier is exposed and drag the soil away also matters enormously. So if there's thick soil sitting on top of limestone, the calcium bank is large. If there's thin soil sitting on granite, the calcium bank is small, the initial bank. And add to that dust and precipitation inputs annually. I won't mention it here, but calcium input from the rain has actually fallen over the last 20 years as we've kind of cleaned up pollution sources. And then we do things. We add calcium chloride as a dust suppressant to gravel roads. We add fertilizer. And in our case, we add wood ash. All of these are the additions to the soil bank. And then there are withdrawals. Well, trees are about 1% calcium, so they're drawing calcium out of the soil. There's a natural millennial-long progress of leaching and stand aging, which removes calcium from the soil. But then in the last 100 years or 200 years, humans have removed calcium from the bank at a much larger rate by clearing the land, logging the land, and taking the pool of biotic calcium away, and especially by acid rain. Acid rain has certainly been the key mechanism which has lowered the rate of, lowered the amount of calcium levels in the soil, the total size of the pool of exchangeable calcium in the soil. So now let me introduce you briefly to the Friends of the Muskoka Watershed. Our vision isn't, I don't think, probably much different from some of the vision statements of the Georgian Bay Biosphere Reserve to keep our watersheds healthy. And we do this, as Daniela mentioned, by working with the local and the scientific community to identify, develop, and foster solutions to watershed stressors. I'll just back up for a sec and tell you that my half century of work has convinced me that we can make a huge difference. It takes only knowledge and will. Will is the hard one, knowledge the easier one to generate in a functioning democracy. And I've come to believe that the core values that underpin the generation of knowledge and will are humility and hope. Humility because it keeps our minds open and recognizes that we're often in error and that individually we're kind of dumb, but collectively we're quite a bit smarter. And hope mainly because despair is no platform from which to solve any problem. So how does the Friends of the Muskoka Watershed attempt to develop this knowledge and foster the will? Well, we track key watershed threats that share three characteristics. They're severe and widespread. They're not being currently addressed by the government. And we think getting the public involved can help foster solutions. We then identify gaps in knowledge that are needed to resolve those problems. We normally have to raise money at that point because it's going to take a couple of years to generate the knowledge to plug those gaps. So let me acknowledge again the Trillium Foundation, who have helped foster the work I'm going to be talking about shortly. And then once we have that knowledge, we work very hard to share that knowledge with the public to generate the will for action and hopefully mobilize those actions. How does that play out in the case of ecological osteoporosis? So I hope I've convinced you we have a widespread problem of low calcium in Muskoka, caused mainly by acid rain. This also applies to the Georgian Bay area. The land there has many lakes with calcium levels low enough that crayfish are dying. I hope I've convinced you that sugar maples are in a bit of trouble right now. So it's a widespread threat affecting most of the forests and over half the lakes in Muskoka. That's why we chose it as the first stressor to address. We next had to identify the gaps in knowledge, which we assume were preventing logical restorative action. I've listed some of them here. There are several kind of scientific or technical questions. How much calcium is in ash? What dose is needed? Is there enough ash? Are there risks? Are there benefits? Will the public share their ash? That's kind of a environmental psychology question. You know, there's kind of engineering questions. How do we add it? There's regulatory questions. Will the government approve it? And all of those are issues we wanted to address with the work funded by Trillium. We got lots of academics involved, as I'll show in a sec. And then once their knowledge is coming, it's not completely available yet, but you'll see it's coming. Then we use all kinds of methods to try and marshal the will for action. So that's kind of the way the Friends of the Muskoka Watershed works. So let's first hopefully try and convince you that adding calcium is not a bad way to go. The most significant experiment that's been done in the world to show that adding calcium can help forests that have suffered decades of acid rain was done at the Hubbard Brook Experimental Forest. It got about the same amount of acid rain for the same amount of time as Parry Sound and Muskoka. And so they, in an experiment done in 1999, added just under a ton of calcium per hectare to a 5-hectare sugar bush. And these are just to show you what happened to calcium levels in the leaves. Not much in the first year, but by the second and third year, a doubling, a 2 to 3-fold increase in calcium levels in the leaves. That led to more chlorophyll, more photosynthesis, kind of shockingly a 25% increase in transpiration, better crown health, more seed production, more seedling germination, better mycorrhiza. Essentially, the forest woke up and had been asleep, figuratively, or at least napping for probably 50 years as a result of calcium depletion. We think the same is true in Parry Sound and Muskoka. Closer to home, an ash addition experiment was done in 2014 over in the Halliburton Forest. Here's calcium levels. The ash was added, either bottom ash, BOT, or fly ash, FLY, at either 4 tons or 8 tons per hectare. And within 2 years, there was more than a 50% increase in calcium levels in the leaves. This experiment has convinced us that we can't wait a century or more for the calcium to recover on its own. We need a new source, and ash from people's fireplaces would be a good source. So the goals of the ASHMuskoka project are to encourage public engagement in environmental protection. Trillium doesn't fund science. Trillium funds public public engagement for societal good. So that's the main focus of the ASHMuskoka project, is to get the public involved by generating Canada's first, we're going to call it non-industrial wood ash recycling program, which is designed to solve an environmental problem. In this case, widespread calcium decline that's affecting forest and lake health. And then along the way, we have to learn how to do it. And this is where the applied environmental science comes in. How much ash is needed, proof that it works, how to get it approved, how to get people involved, etc. This project is 2.5 years into, or 2 years into a 3-year mandate. It includes lots of partners. I'll introduce them briefly. The Ontario Maple Syrup Producers Association, the 3 sugar bushes that I mentioned in the acknowledgements. Municipal government is working with us to help us host ash drives. The Dorset Environmental Science Center has helped us with measuring the chemistry of the ash, and and actually with lots of things with experimental design. They've been wonderful partners. There are 3 universities that I'll talk about in a sec. The Muskoka Steamship and Discovery Center in Gravenhurst has been helping with public outreach. We have a large display on the ash project there. We're working with West Wind Forest Stewardship, hopefully to help us roll out the project once we learn how to do it down the road. And Camp Big Canoe, children's education camp in Bracebridge, has a large, wonderful forest that hasn't been logged in a century, and we're testing doses on their site, as I'll show you in a minute. I just want to introduce the 3 academics that have been involved in the study. Chantal Berriot, Dr. Berriot runs the science communication program at Laurentian, and we have worked with Laurentian interns to make videos on the calcium decline in ash problem, which you can get on our website. This is a wonderful, one-of-a-kind program in Canada, which I hope the Biosphere Reserve works with as well. Their interns are terrific. I've never worked with an environmental psychologist before, but that's, if you're in the business of trying to generate will for action, you have to understand the roots of will. And Bob Gifford and his postdoc, Leila Scannell, have been wonderful working with us, trying to understand what would motivate people to get involved in ash recycling. And then Dr. Watma, whose work I've introduced briefly, we have a number of his students involved doing these projects on figuring out the houses, risks, and any benefit or benefits and any risk for the trees, and also work on fertilization policy. Right now, you're not allowed to add ash generally to crown forests, for example. He has a graduate student who's evaluating forest fertilization policy in Ontario. But the most important participants are the public. Won't it be nice when we can get together like this again? Maybe not to drink beer in public, but just for any such public event. So we have currently about 1,200 people in Muskoka, almost entirely in Muskoka, that are sharing ash with us. And some have even come from further away. We have one chap that drives 6 hours from Manitoulin Island each year to bring us 3 pails of wood ash. I'll just give you a little bit of the science. So one of the gaps in knowledge was, is there enough calcium in wood ash that it will make a difference? So the first work that we did in a pilot study in 2017 and 2018 was actually to gather ash from local fireplaces and wood burners, people that heat with wood, and look at the chemistry of the ash. And again, thanks to the Dorset Environmental Science Center for help with this work. The ash was 30% calcium, that's that column, and there was very little variation between wood burners. So 30% calcium is almost enough, as much calcium as in the mineral calcium carbonate, and is as much as in dolomite, which is a calcium magnesium mineral. So lots of calcium in the ash, plus several other minerals which are important to forest health: potassium, magnesium, sodium, and phosphorus. The potassium will turn out to be important in the work that I show you. So the ash is about 30% calcium and about 7% potassium. The important thing is this potassium is very soluble. The calcium is less soluble. So the calcium in the ash is kind of slow release. The potassium is quick release. In case anyone's wondering what these little dots are, I'll just tell you that we had one unusual ash source that had more potassium, magnesium, and phosphorus. And that was the only ash provider that came from a wood-fired pizza oven. So we think these high levels were because, unlike all the other wood stoves which had only firewood, the pizza oven had firewood and pizzas, which are full of flour, And flour has a lot more phosphorus and magnesium and potassium than wood. That's why we had this one unusual source. We told this pizza baker he could market his pizzas as producing the best ash, the most nutritious ash in Muskoka. Here's my most complicated slide. What you need to look at is the yellow boxes. We compared our non-industrial wood ash with industrial wood ash in Canada for the 11 metals of concern to the Ministry of the Environment: arsenic, cadmium, chromium, cobalt, copper, lead, mercury, molybdenum, nickel, selenium, and zinc. If any one of these was coded blue, this is this column, that would mean that we couldn't use that ash. Anything that's colored yellow means the level of that metal was just a higher, in this case, just a tiny bit higher than the level at which the Ministry of the Environment said you can use it wherever you want. So it just means we had to measure the metal levels in the soil, and the Ministry of the Environment was very happy that we could use the ash, that we have approval to use the ash. They don't expect any contamination from it. But I'll just note that our non-industrial wood ash is often much cleaner than industrial wood ash, sometimes more than 10 times cleaner, here 4 times, here almost 100 times cleaner for that metal than industrial wood ash. So we don't really know why, but we were reassured by that. So what are we doing? We're securing approvals to add ash to the forest, determining affected ash doses, looking at risks and benefits in 3 sugar bushes, then scaling up to much larger plots at Camp Big Canoe, and then hopefully reporting all this to the public. So working. Well, the first thing to point out is lots of people have been interested in participating in the project. Here are 3 people that have come to our office to pick up their ash collecting bucket. Thanks to Gravener's Timber Mart and Mummer Bear's Ice Cream for helping us with the buckets. Not all men took the little buckets. Lots of men took the big buckets and lots of women took the small buckets. But I'll tell you, everyone's very happy when they come to our office to get their bucket. And again, we've got about 1,200 people bringing us ash. They then bring that ash to a local Rosewarne transfer station in Bracebridge. Here's the deputy mayor of Bracebridge. He's just brought his ash. We then screen that ash to remove coarse particulates and run a big magnet through it, even though we tell people not to burn industrial or wood with nails and screws and hinges, and they often do. So we have to screen all the metal fragments out of the ash. Here's me and Neil Hutchinson in our chair, Peter Kelly at an ash drive. It's a lot of fun, but messy. We then take that trucked, screened, approved, analyzed ash. Here we're delivering a ton of ash to Brooklyn Farms, where we had 12 plots. We then weigh that ash out into typically 10 kilogram buckets like this, and with lots of white-haired and younger grad students carry it into the bush and sprinkle it on plots. Here you can see the blue pipes. This is in the middle of the sugar bush, and this is what 8 tons per hectare of ash looks like scattered on top of leaves in the fall. So I'll show you a bit of results. For those of you that remember your high school chemistry, pH is a measure of acidity, and the lower the number, the more acid, and it's a log scale. So a change from say 4.5 to 5.5 is a 10-fold reduction in acidity. So I've reduced Batul's data here, about 700 measurements, 5 samples from 3 depths from 5 months, from 3 treatments, control 4 ton and 8 ton per hectare in 3 sugar bushes, crunch that all down into 9 numbers. So in the litter layer of the soil, there was a 100-fold reduction in acidity, and it was dose dependent. In the next layer down in the soil, what's called the FH layer, or the fibrous humic layer, also a 100-fold reduction in acidity, and even in the mineral layer after 1 year, a reduction in acidity. Very promising. But what's more promising is we're seeing an increase in calcium levels initially in seedlings. This is after 1 year. So this is maple seedlings, where we got a 50, 100, and more than 150% increase in calcium levels in the leaves, shoots, and roots of seedlings after 1 year. So we expect this. We don't necessarily expect it immediately, because remember, it took 2 years at Hubbard Brook to see this effect, but we're seeing it within 1 year in seedlings. What we see very quickly is the increase in potassium levels in leaves of mature maple. So here is also Batul's data after 1 year from the 3 sugar bushes, Brooklyn Farm, Will Creaser's bush, Mark Lupton's bush. 3 treatments, multiple replicates in each bush, control 4 ton, 8 ton, control 4 ton, 8 ton. And you can see at least a 50% increase and a dose-dependent increase in potassium levels in leaves after 1 year. Why does that matter? Potassium is very influential for sap flow, which I'll come to in a sec. So we expect that restoring calcium will have all these benefits. This was, again, the graph from Hubbard Brook. They only added calcium. They didn't add potassium. So so they didn't add ash. They added a pure calcium silicate mineral. We added ash, which has 30% calcium, 7% mobile potassium. So let's have a look at what that might have done. So here, let's go to Camp Big Canoe. So here we had much larger plots. They were 16 times larger than the plots in the 3 sugar bushes. And this is not a managed bush. This is more a forest. So here we're looking at the maple and the beech and the hemlock. These are graduate students from Trent University. Here's Shelby, here's Ann Silby, all doing different projects. And I just want to show you kind of what it looked like from the air. We have this 10-hectare area that the Ministry of the Environment has approved our adding as much ash, more or less, as we want. And we have 12 fairly large plots, 40 meters by 40 meters. And they are either control 6 ton per hectare or 2 ton per hectare plots. Here's what, and we decided to look at sap. So here's now my link between Fireplaces and maple syrup. And we actually had an impact which I consider shocking. We tapped 12 trees on the 6 ton per hectare plots and 12 on the control plots, 1 spile per tree. And the spring after we added the ash, we had almost double the cumulative sap volume per spile on the plots we had added the ash to. And if we look at the sugar content of the ash, and I'll thank Shelby Conker for these data, Shelby from Trent, our staff collected all the sap, sent the sap to Shelby at Trent University. During the time of high sap flow from the middle of March to early April, the sap coming out on the ash plots was actually sweeter. So this is essentially percent sugar, even though it has this name of bricks. Later on, when the sap more or less stopped flowing, there wasn't any difference. But early on, when the sap was flowing dramatically, that we actually got more sweeter sap from the ash plots. So we shouldn't be surprised. We would now predict that we're going to end up with more sap and sweeter sap if we can fix this ecological osteoporosis problem in the forest. We don't know yet how much calcium versus potassium are contributing to this. We just know that we had a real impact, and hopefully Shelby in her master's thesis will explain it for us. But we shouldn't be surprised because others have noted that liming sugar maples in Canada leads to more sap production in the long term. And that's great economically, but what I care about more is just making the trees healthier and waking them up after half a century of slumbering because of low calcium availability. We're thinking of issuing a 2-ton to the people in the climate and having many other benefits. Calcium, can you all still hear me? I've just got a note that I have an unstable connection. Daniela, is everything okay?
It cut out just at the beginning of this slide, but it's better now.
Okay, thank you. Calcium stress weakens wood strength. So wood is about 30% weaker if the trees don't have enough calcium. So we think this will increase the resilience of trees to wind damage. Calcium is also involved in signaling of trees. So we think there's relevance for pathogen effects. There should be somewhere between a 25 and 50% increase in carbon capture. For your interest at Hubbard Brook, over that long-term experiment I described, the addition of calcium has led to the capture of an additional 1 ton of carbon per hectare. Think about scaling that up over tens of millions of hectares of land in Eastern Canada. There's been a 25% increase in transpiration rate of the trees. We think this has implications for spring floods. There is lots of calcium-rich life on the land and in the waters of our watersheds and should benefit them. So we think dealing with this legacy of acid rain by issuing and realizing this 2-ton challenge across our watersheds will have many benefits. The work that the Friends is doing to try and understand these benefits, on the left is the work we're currently doing, looking at the effects of, with Trent University, so looking at the effects of ash additions on the health and growth of a few trees, ensuring that we're not causing a toxic metal problem by adding ash to the forest. One of the students, Anne Sylvia, is looking at calcium availability in the ash, and then collectively with Trent, looking at maple sap production and quality. This is the work we hope to do over the next couple of years to look at. We've started this work on carbon sequestration by looking in much more careful detail at the growth rates of trees by adding what are called dendrometers to 40 sugar maple at Camp Big Canoe. We hope to work with kids at the camp to look at the biodiversity of invertebrates, mollusks and insects in the forest on ashed and non-ashed plots. But the real big one for me from Muskoka, or one of the big ones, is transpiration. If they're really, we have a sense that our soils have been too wet for the last 50 years. Trees are not pumping as much water as they used to for thousands of years before that. Anyway, so that's what the Friends of the Muskoka Watershed is doing to combat ecological osteoporosis. Please have a look at our website so you can keep up with what we're doing. And I'd invite you to consider whether in your own area you might like to start an ash program in the Biosphere Reserve. And if so, we'd be happy to help you. We've just produced about a 50-page guide to launching a residential wood ash recycling and forest soil amendment program, and we'd be happy to share that report with you. And thank you very much for listening. And I'll be very happy to take any questions you might have. And I'll stop sharing my screen.
Thank you so much. It's fascinating work. And I had questions as we were going, and then you kept answering them. But we have a great question in the Q&A. Has anyone done any work on the relationship between calcium levels and beech bark disease?
There's a very active program going on right now, run by West Wind Forest Stewardship in Southwest Algonquin Park, adding ash to beech maple stands, in particular to look at that interaction. And what they don't think the ash will help the beech deal with the beech bark disease, but what they're very interested in is knowing, can adding calcium help the forest recover, the sugar maple recover after the beech disappear? So that's as much as I know. We will, at our Camp Big Canoe site, we will be looking at the health of beech and maple and hemlock over the next couple of years. And so we might, if there's any interaction there, if any of those trees aren't diseased yet, but if they are, we could then compare our control plots and our ash plots to see if it might have made any difference to have calcium fertility in the soil back where it should be.
Excellent. When you look at the list of forest pests and diseases that are either here or on their way, it does affect almost every genus, if not species, of tree in the forest. So it's exciting that this could be such a huge help, really.
There is clearly trees that are starved with not enough calcium do not combat parasites and pathogens as well as they should. So it's kind of a threat multiplier for various things. The wood is weaker, their signaling goes down, their ability to communicate with plant hormones in the tree is weakened. So it's amazing to think that, my entire life I've been growing up in an unhealthy forest that I didn't realize was unhealthy. And that's a legacy of acid rain. So it's shocking that you can add ash and the next year you can increase sap flow by 50% or 100%.
Yeah. We do have a couple more questions that have come in, which is excellent. Please, again, that Q&A button at the bottom is wonderful if you have any questions, big or small. John asks, what exactly is industrial wood ash and why would the metal levels be so high?
Okay. So our funding comes from Trillium, right? Trillium doesn't fund research or industry. Trillium funds public engagement. When we looked at the available sources of ash in Canada, there was about 10 times more industrial ash than non-industrial ash. So industrial ash comes from cogeneration plants, power plants that are burning biomass. Historically, coal-fired power plants generated thousands of tons of ash. And so all of that is considered industrial ash. The federal government had a fairly large program to look at the chemistry of that industrial wood ash. And if you Google AshNet, you'll find access to those data sets. But no one was looking at residential wood ash or commercial wood ash from like pizza bakeries. And we thought there was enough of it. Muskoka generates 300 to 400 tons a year of residential wood ash, and we initially just called it residential wood ash, but when we added the pizza bakeries, we realized it was residential and commercial, so we just call it non-industrial wood ash. Why the industrial wood ash has so much higher metal levels, we don't really know, except that they're clearly, it's not coming from the wood itself. It's somehow coming from the processing, because it makes no sense to me that somebody is burning wood that'll have 100 times the cadmium levels in an industrial plant than my neighbor has burning it in his fireplace. It kind of starts as the same wood. The other thing I just might mention is the wood that we're burning is typically 50 years or 80 years old, right? Those trees. Those trees were growing at a time when the atmosphere was much more polluted than it is today. Every year, the trees are probably getting cleaner. For example, levels of lead in maple leaves today are 100-fold lower than they were in the 70s when we used leaded gasoline. Levels of cadmium and mercury and zinc and chromium are lower in leaves today than they were 50 years ago. So I think our ash is going to get cleaner every year. And 50 years from now, when we fully launched our 2-ton challenge across Canada, I don't think there'll be any issues with metal contaminants in the wood, because the wood that people are burning at that time will be cleaner than it is today.
Very interesting. There's a number of questions about volunteer help. So can people out of your immediate area contribute their ash if they transport it? And what type of container would be necessary to do that?
Sure. As I said, we have one chap that comes from Manitoulin Island, drives for 6 hours to bring us his ash. We have ash. If you go to the ASHMuskoka website and register, you'll get monthly communications about our ash drives. Right now, the only place we're allowed to hold them is at the Rosemorne transfer station in Bracebridge. We sure hope that changes. There's no reason why a transfer station in Parry Sound, for example, that has approval for handling potentially hazardous waste can't get approval for holding ash drives locally. But it would take local volunteers to organize that with the municipality. So we had all kinds of meetings with the district. It didn't, I'd say half a day's worth of meetings over a few months to get approval to hold ash drives at the Rosemorne transfer station is really all it took. And then, so we've collected close to about 20 tons of ash. So we've diverted 20 tons of ash from landfill and have generated 20 tons of what we think of as a forest soil fertilizer that we can now use. So right now, the rules are changing, we think, over the next year. Right now, you're not allowed to add ash to Crown land, for example, but we think that is going to change within the next year. But right now, you absolutely need government approval. Places like Sweden are way ahead of us. So for the last 30 years in Sweden, there's quite a circular economy with forestry that they'll log and then take the wood they want for pulp and lumber. The slash goes to a cogeneration plant. The ash from the cogeneration plant is taken back to the forest. That's what we need. Now, let me quickly add, we're not encouraging people to start burning wood if they're not doing it now. There are certainly better ways, more climate-friendly ways in the long run to heat your home. But if burning wood is what you do because you live in the country and you're not on a gas line and you're not generating solar power, so burning wood is what you do, then we're hoping that this is a useful thing to do with that ash to get it back to the forest.
And that's a great segue into the next question from Renate. Is there any information for the homeowner who has a large number of trees on their property, like a how-to guide really to use their ash to nourish those trees?
Yes, again, if they send ASHMuskoka an email, we can give them information we have. So what I'll say is, number one, make sure the ash is cold, cold, cold. The last thing we want to do is start fires. We actually had one of our ash collectors burn down their garage because they thought the ash was cold and it wasn't, and it set their garage on fire. Number two, take a look at your sugar bush. If you have thin soil with lots of hardwoods, chances are, and you're in Parry Sound, chances are your forest is not fully awake and suffering from calcium decline. So on your own property, after the ash is cold, we think 2 tons per hectare, if you can work that out, 2 tons, like send us an email, we can help you with that. 2 tons per hectare is, we think, the amount that you will need on your own property, and you only have to do it once because it's recycled by the trees. For example, at Hubbard Brook, they did that one addition of 0.8 tons per hectare of calcium, and they think that will increase photosynthesis and carbon capture forever because they're not logging that particular forest. You know, if there's some other, if you're logging it heavily and taking biotic calcium away, you're going to have to do it. You're going to have to add more every decade ago. Every gardener understands that. If you're stripping nutrients out of the soil by harvesting the crop, then chances are you're going to have to add more nutrients. We need to think more like gardeners of the forest, not miners of the forest, when we're thinking of ash. However, if the questioner is has mainly a conifer forest, conifers don't need that much ash, or if the soil is thicker, then give the ash to us. We'll do something very useful with it for the benefit of everyone in Central Ontario. Or launch your own ash recycling program in Parry Sound, and the Biosphere Reserve will help you set it up.
That answered a couple of questions on the list from people wondering if they should be doing this and how much and so on. Another important question though, what about like waterfront property owners? Like should phosphorus and wood ash be concerning for algae blooms in lakes as runoff?
Well, that's a fabulous question. And the answer is no, you don't need to be worried. One of the earliest studies we did in this first year when we were assessing risks and benefits, the Ministry of the Environment wanted us to analyze all the metals. And we added to that studies of toxicity and studies of the solubility of the elements in the ash, including phosphorus. So the ash was about 1% by weight, but it was insoluble. It will vary. And the other thing is, if you're adding it to the forest, the only reason to really be worried is if the place that you add it is seasonally inundated. So if it's an area that is connected to the local hydrologic regime because it floods in the spring, and then anything that might be mobilized by that floodwaters gets to a lake, that's the only time you would need to be worried. But even then, the phosphorus in the ash is apatite phosphorus and is very sparingly soluble. So we're not concerned about that risk, but it's an excellent question. I would never be promoting this if I thought there was a risk of eutrophication of lakes.
Of course. And I think that question, I'm not sure if that person attended our last webinar. We had one in November or December about Parry Sound 33 forest fire. And in that instance, there was issues with phosphorus in the water and algae blooms as such, but the scale of these two situations is entirely different.
Okay. Yeah. The other thing just to mention, and people have asked about fires. Are fires good because they mobilize the ash or mobilize calcium in the ash? And the answer is they probably do, but they don't add new calcium to the watershed. So if calcium has been lost, that 0.5 ton of calcium per hectare that's been lost from the watershed over the last half century of acid rain, that lack is not going to be fixed by a local fire.
That's a great point. So Juliet asks, do you add the ash in the fall only?
We have so far. There's no particular reason for that, though, other than it matched when we got our government approvals to add it. You will not get approval to add it on top of snow because the government still treats it as a potentially hazardous waste. They know it isn't, but they don't have a regulatory box for forest fertilizers. So they have to manage it by the closest box they have. And that closest box they have, believe it or not, is biosolids or sewage sludge. So they kind of manage ash as if it is sewage sludge. And so their biggest concern is actually ammonia, which can come out of sewage sludge. So they know full well there's essentially no nitrogen in ash. It's the only nutrient that's missing, actually. If you think of NPK, the normal nutrient mix in garden fertilizers, there's very low N in ash because it's burned off in the fires. Another very good question I'd asked is, well, if there's no nitrogen and nitrogen limits forest growth, of what benefit is the calcium that you're adding in the ash? So, and the answer to that excellent question is that if this was 150 years ago, you'd be right. There's no benefit. But a third of all the acid rain was associated with nitric acid. So we've had almost half a century or more of excess nitrogen deposition to our soils. Our soils are rich in nitrogen because of acid rain. And so this is the one situation where adding a nitrogen poor fertilizer actually makes sense. So all of Eastern Canada suffered from acid rain, and pretty well all of it, all the mixed hardwood forest growing on, okay. If you're in Eastern Canada, thin soil on granite, then those conditions which apply to vast swaths of the Eastern Canadian mixed hardwood forest will benefit from the addition of ash, despite the fact that it has very low nitrogen.
All right. We do have 3 questions left, so this will be kind of a last call out for questions in the Q&A tool, if you would please. The question reads, how much wood ash from volunteers would you need to be sustainable? I know you referenced that 2-ton challenge. Is that sort of the rule of thumb?
That's a huge question. And one of the questions we had to answer was the dose. So we're settling on 2 tons as what we hope will be our final selected dose, in part because the ash is 30% calcium by weight, and we lost half a ton of calcium per hectare. And if you do the arithmetic and assume that all the calcium in the ash will ultimately be available, 2 tons replaces all the calcium that was lost with a little bit to spare. And you should only have to add it once, unless you're routinely logging the forest. So now let me remind people that environmental problems are generated typically, unless it's a major spill. The acid rain problem took decades to create. It's not going to be solved overnight. We generate 300 tons of ash per hectare a year in Muskoka. At 2 tons per hectare, that means we could fix 150 hectares per year of the tens of thousands of hectares in forest in Muskoka. It's not going to happen right away. But there's lots more ash produced than that. There's industrial wood ash, which no one's using. There's ash across southern Ontario where it's not needed. We have trucks taking compost from Muskoka and Parry Sound to southern Ontario every day that come back empty. They could be bringing southern Ontario ash back up to Muskoka. If we held ash drives in Guelph and Waterloo and Kitchener and London, that would take work to organize, but it's doable. So in my mind, let's remember, I'll give you an analogy. We didn't get rid of the phosphorus from sewage once, and then the problem went away. We have to have ongoing management of the phosphorus problem in lakes, in sewage, to keep our lakes healthy. This is no different. It's actually better, because once we do the whole country once, we probably won't have to do it again. So it's better than the phosphorus problem. If we can get the forest calcium back to where it should be sustainable. The federal government has set a 30-year time horizon for carbon neutrality. I think that's a nice target to adopt. Let's see if by 2050 we can get a 2-ton challenge solution rolled across Eastern Canada. Daniela, you don't have white hair like me, so I'll give that challenge to you and your peers, and I'll help wherever I can.
That's good. So our last two questions, both things we've touched on a little. There's another forest pest question about increased calcium levels, making foliage less appetizing for LDD caterpillars.
Less appetite for what?
For LDD caterpillars, formerly called gypsy moths. Yeah.
Okay. Sorry. Well, you've entered an area. I have to now tell you that I'm an animal plankton ecologist, come only lately to forest health. So I don't really know the answer to that. From the reading I've done, and I'll go back because that's such a good question, and I'll do a little more reading now. Trees, the signaling in trees, within the tree and between trees, is a calcium dependent pheromone or phytochrome dependent mechanism. So all I've read is that trees somehow can deal with parasites and pathogens better if they're not limited by calcium, but I don't know the mechanism. So I don't know if it particularly would apply to what used to be called gypsy moth or not. Okay. But I'll do some reading about it. Yep. And I'll send you an answer that you can pass on to your reader or to your questioner.
Our last question from Carrie. You have referenced a few times other species of trees, and Carrie just asks if you're planning to specifically test the effect of ash on other types of trees.
Oh my God, I'm so glad you finished with that question, because it makes me realize I've forgotten one huge message, which is that the Friends of the Muskoka Watershed is hoping to launch a citizen science ash addition project, which will absolutely target other trees. If you're interested in participating, and if enough people, for example, say, we want to work on tamarack, then we'll see if we can help. If only one person wants to work on tamarack, it's not good science. But if 5 people do, then we have replicates and we do our best to add it. So please send an email to, are you ready for this, Katie? katie@fotmw.org. And Katie, we hope, will be running our citizen science ash addition project.
I will also include that email and that information in the follow-up email that you can find tomorrow.
Okay.
So there's no further questions. So I just want to say thank you so much, Norman, for this presentation. It's been interesting beyond belief, really. And thank you everyone for taking some time to join us today. And I hope it was really valuable for you as well. And if you keep an eye on the Biosphere's social media platforms, we also have a monthly newsletter. You'll hear about some more webinars that we are lining up for 2022. So we hope to see you virtually then, and have a wonderful day and try to stay warm out there.
Thank you everyone for hanging in there.